So similarity. When we have two shapes that are similar, that means that all the sides are proportional, which means all sides are being multiplied by the same number. All the angles in similar shapes are congruent, which means all the angles from one shape compared to the other shape, they have the same angles. When we're dealing with triangles, we can prove that triangles are similar when at least two angles in our triangles are congruent, or we can prove that two triangles are similar when all three sides are proportional. Don't worry too much about this right now. We'll work more on it later. Now, transformations. Remember, in transformations, the words that we use are translation, rotation, reflection, and dilation. Oops, dilation. Out of those four words, the one that we use to create a similar shape is dilation. Okay, so this word, notice it's in a box. When do we think it might show up again? Box things usually tend to show up on test day. All right, so if it says we're using a rigid transformation, these three are rigid, which means the shape itself is not changing. That's not true for similarity. In similarity, our shape is going to change. The size of the shape is going to change. Okay, so dilation is the transformation that we're using for similar shapes. All right, not rigid transformation. All right, moving on. Triangle JKL is dilated by a scale factor of 3/4. So dilated means we're going to change the size of the shape, but the general shape stays the same. And how are we changing the size? We're multiplying by a scale factor of 3/4 to form a new triangle, so that J prime goes with J, K prime goes with K, so it goes like that, right? So what I'm going to do is first they ask, what is the measure of side KL? All right, the new KL, right? So I go to my old KL, and my old KL is right here. Okay, I actually made a mistake right there. So this old KL is right there, right? So I'm going to take that 48, and I'm going to multiply it by my scale factor. So 3/4. Well, let's see. 48 divided by 4 is 12, and 12 times 3 is 36. So we have 36. So my K prime, L prime is 36. All right, new KL, old KL. After my scale factor, notice that my new KL got smaller. Why? Well, because we're multiplying by a number that's less than 1. All right, moving on. Okay, so triangle NOP is similar to triangle QRS. So first thing we have to do is to figure out, how do these triangles even match up to each other? So let's see. Notice that NO goes with QR. So I'm going to pick a color. Here we have NO. Here we have QR. Okay? Well, there's nothing on both of those, so that doesn't help me. All right, moving on. OP, looking at the second letter and last letter. OP goes with RS. I'm looking at the order of the letters. So let's see. OP goes with RS. There we go. Those two go together. And then that means that these last two also go together, the ones that don't have colors on them. Okay? So now it says solve for SQ. Well, here's SQ. I'm going to put an X over here. Okay? So now we have green goes with green. So let's see. 22 divided by 5 is equal to. Notice I started with this one. I just chose to start with that one. It doesn't matter. You could start here as long as you follow the same pattern both times. Okay? So I said this was my first thing that I put, then this is going to be the second thing I put. So 22 divided by 5 is x divided by 7. So x goes with 7, right? Blank goes with blank. So x goes with 7. Now to solve this, we're going to cross multiply. So this gets multiplied with that, and this gets multiplied with this. Alright, so we have 22 times 7. Oops. Is equal to 5 times x, right? Cross multiply. Alright, so from here, to get x by itself, we have to divide by 5 on both sides, right? So, because I want x by itself, so then this 5 moves over here, divide by 5. Alright, now this is what I can put in my calculator, right? Divide by 5, get rid of that, x is by itself. I put this in my calculator, okay? When I put that in my calculator gets back with 154 divided by 5. I can keep it as a fraction like that. Nope. My answer specifically tells me round to the nearest tenth. So I have to put that in my calculator to say, hey, I want a decimal answer. And when I do that, I say, hey, I want a decimal answer, we get x equals 30.8. Okay, this was converted to a decimal. Alright, moving on. Try it again. Alright, let's match up our triangle pieces. BC, first two letters, goes with EF. BC, right here, goes with EF. Alright, CD, last two letters, goes with FG. Last two letters, which means this blank goes with that blank. Let's set up our ratios. This time I'm going to choose to call this my triangle 1, this my triangle 2. Does not matter which order as long as we're consistent. So I'm going to match up my triangle 1. Let's see. Yellow goes with yellow, so 14 divided by 59 equals, I said this was triangle 1, so triangle 1, 25 divided by x. Cross multiply, so 14 times x equals 59 times 25. Alright, I want x by itself. How do I get x by itself? I'm going to move this 14 to the other side. How do I move it? I divide by 14 on both sides. Cross this out. Okay, so that's what goes in my calculator. So control divide so that I can enter it as a fraction. 59 times 25 divided by 14. And I'm going to put a little dot after my 14, a little decimal point to say, hey, I want a decimal answer. And it'll give me a decimal answer, 105.35. So x equals 105.35. Solve, round to the nearest, oops, I meant to say 10th on this. So we're going to round to the nearest 10th, so that's 105.4. Let's do a little common sense check, okay? Notice that the triangle is getting bigger from here to here, alright? And does it seem to make sense that if this is 14, our new triangle is 59, if this is 25, yeah, it seems to make sense, alright? If we ended up with a smaller number, then we would have been like, something didn't work out right, okay? Alright, moving on. Alright, are the two triangles below similar? This is where we go back to the beginning to say, hey, how do we prove triangles similar? Angle, angle, similarity. If two angles of triangles are congruent, then we have similar triangles. Well, let's see. First thing I notice in both triangles here is that they both have this 53. Great. But the problem is, I see this triangle has 67 and this triangle has 60. So at first glance, I'm thinking, no, they're not similar, right? But then I'm like, I know that all the angles in a triangle add up to 180, so let me see, what is this missing angle right here? All the angles add up to 180, so we have 53 plus 67 plus x equals 180. Let's combine like terms. We get 70 plus 50 is 120 plus x equals 180. Move the 120. I get x equals 60. So that means this right here is 60 degrees. Alright, at first glance it looked like we only had one angle that was congruent, right? The 53. But now that I know that this angle here is 60, do we have two angles that are congruent? Yes, we do. We have that 60 and the 53. So therefore, these two triangles are similar because we have two congruent angles using angle-angle similarity. Okay? Now, you might want to go and also solve for this, but let's see. All three angles added together have to add up to 180. 53 plus 60 plus 67 adds to 180. So this one has to be 67. That's why we only actually have to say two angles are congruent, because if we know two, we know the third has to be the same because they all add up to 180 on both triangles, right? This is enough. All right, moving on. The other way that we can prove two triangles similar is saying that all three sides are proportional. So we have to check all three sides. We're going to check our short leg. Let's see, our short leg right here is this one. Between all these, this was the shortest. 12 is the smallest number. Over here, let's see, which one's the smallest number? Right here. This is our shortest leg. Where's our longest leg? Longest leg is here. And our longest leg is here, which means our medium is right there. And we're just going to match them up. All right, short divided by short. So 12 divided by 60. And then we're also going to check, we have to put that in our calculator to see what we get. Medium divided by medium. So 16 divided by 80. And our long, 20 divided by 102. All right, we put all three of those in the calculator. So 12 divided by 60. My calculator says this is 1/5. 16 divided by 80. My calculator says this is 1/5. If we get 1/5 here, then we have similar triangles. If we do not get 1/5 here, we do not have similar triangles. Let's see, 20 divided by 102. My calculator does not say 1/5. It says 10 over 51. So therefore, do we have similar triangles? No, because we don't have the same ratio for all three sides of our triangle. So therefore, not similar. All three would have had to have the same ratio. Okay? Alright, moving on. Solve for the perimeter. Remember, perimeter means we're adding the outside sides. Alright? Well, it wants the perimeter of this smaller triangle, JKL. So, in order to do that, I first need to solve for this x. Well, to do that, I need to match my sides. So, notice over here, this piece right here, I'm going from 54 to 88. Looking at my angles, going from 54 to 88. So over here, 54 to 88, that's this angle. All right, so these two match. Let's match the other ones. My x is 38 to 88. 38 to 88 over here is this piece. Okay. Now, do I need to also match this one? No, we're not trying to prove something similar. We need two sets to be able to solve for x. I can just ignore this last one. All right, so let's go ahead and I'll call this my triangle 1, I'll call this my triangle 2. It doesn't really matter which, if you say this is 1, this is 2, as long as we follow the pattern. So triangle 1, we'll say 66 divided by triangle 2, 33. Yellow, triangle 1, 88 divided by triangle 2, which is x. So we had green divided by green, yellow divided by yellow. Okay? Alright, now cross multiply. So we have 66x equals 33 times 88. Alright, now how do we get x by itself? Divide by 66 on both sides. Alright, this is what goes into our calculator. Actually, this one I'm pretty confident on my mental math for, because 33 divided by 66 is 1/2. So we have 88 divided by 2, I get 44. So we get x equals 44. But if you're not confident on your mental math, then put this in the calculator, you'll get 44. Alright, now the problem is we solved for x. Did it ask us to solve for x? It did not. It said solve for the perimeter. Perimeter, we need to add all three sides. So this right here is 44. Now let's add all three sides. Perimeter is equal to 44 plus 54 plus 33. Alright, this is what goes in my calculator. And we get perimeter is equal to, let's see, let me put it in my calculator. And when I put that in my calculator, I get 131. Okay? Alright, last one. Alright, to indirectly measure the distance across the river, Hua stands on one side of the river and uses a sight lines to a landmark on the opposite side, on the opposite bank. Alright, so far they haven't told us anything important. Alright, Hua draws the diagram below to show the lengths and angles that she measured. Find PR. So PR, that means our X is this right here. This is our PR. Okay? Round to the nearest foot. So, it says that she put her angles in the diagram. Notice the only angles we see is that these two are right angles. Well, what does that tell me? Let's see. First of all, do we have similar triangles? Actually, yes, we do. We have a right angle on both. The small triangle right here. So x 285, and then we have the big Then we have the big triangle that goes from here to here, right? This right here, not a triangle. We have to include the whole thing for our big triangle. So let's see, this piece right here is 375. And what's this length? Well, this piece is x, and this down here is 155, so together we have x plus 155. I should have gave myself room to write the x plus 155. I'll have to do it sideways. Okay, so this piece right here, x plus 155. Alright, now we have our two triangles, and how do we know that they're similar? Well, they both have a right angle right here, and they both share the same angle P. This is the same on both, right? They both have that angle right there. So we have two congruent angles, therefore we have similar triangles. Alright, now let's match our pieces. Well, we go from this angle to here, to our right angle, so these two pieces right here with the x's match. So we have x divided by x plus 155. Those two match. So small matches with that small, and then this bottom matches with this bottom. So 285 divided by 375. Alright, now cross multiply. When I cross multiply, I get 375 times x equals 285 times x plus 155. Well, notice I still have to distribute here. Okay? So when I distribute there, I get 375 here, we didn't change anything, x equals 285x. And then right here, I get whatever 285 times 155 is. Okay? Now I want all my x's on one side, which means I have to move this to the other side. Minus 285x. Okay, that crosses out. Alright, 375 minus 285, I'm pretty sure that's 90, yes. So we have 90x is equal to 285 times 155. I need my calculator. Ooh, long number. 44175. Alright, now to get x by itself, I'm going to divide by 90 on both sides. And some of you guys might be like, couldn't we just end solve? Yeah, you probably could have end solved. Alright, it's just not always going to be there though. Alright, so now when I divide by 90, I put this in my calculator. I get x is equal to 490.83. Done, right? No, not done. Why? I still have to go back and check to see what did they actually ask for. They asked for x, yes, but they asked for x rounded to the nearest foot. Nearest foot means whole number. Alright, so how do I round to a whole number? Well, this is my whole number where the 0 is. Does the 8 push that 0 up? Yes, it does. So I ran out of room to write, so I'm going to go ahead and put it up here. PR is equal to 491 feet. That's rounded to the nearest foot. Alright, good luck with it.